All right, so these are multi-step factoring. Normally I would give a cruel chuckle with these, but not today. I'm not feeling it. Now, you always start these by seeing what you can factor out. Now, 9 and 36 both divisible by 9. So you take out that 9, you're left with x squared minus 4. Are we done? Heck no. Definitely not done. Because this is a difference of two squares. So the 9 stays, but this factors into x plus 2 and x minus 2. Okay? So now it's complete. So there's multi-steps here, thus the name multi-step factor. Now, next up, 12, 36, and 27. They're all divisible by, I'm going to say 3. Yeah. If you factor out a 3, you get 4n squared plus 12n, and then plus 9. If you hear me pausing, that's because I'm doing this problem for the first time in a year. I have no idea what I'm doing. I'm just trying to do math. Now, the 3 stays on the outside, and we have to figure out how in the world we can factor this. Now, you could either use just bubble method with this, or you could realize that this is a perfect square trinomial, because that's the square of 2n. This is the square of 3, so might as well 2 times 2n times 3. Yep, I get 12n. So this is 2n plus 3 and 2n plus 3. Or you could write the answer 3 and then 2n plus 3 quantity squared. Couldn't do that over here though because those are different. Okay? Okay. Now this one, ew, fraction, gross. So if I take out a 1/2 though, x squared minus 1, and we're done. No, we're not, Mr. Byrne. Tighten up. And here's what we got. This is the difference of two squares. Two squares being subtracted. So this is going to factor into x plus 1 and x minus 1. All right? I'll work on it, Mr. Byrne. Thank you. Now, next up, we're going to factor out a -6 from the next one. Okay, well, that's fine. I'm left with z squared minus 100. Now, plus 100. Now, I about messed that one up. When you factor out a negative, you divide each of these by a -6. You get a plus 100 there. That would have been a problem. Now, can I keep going? Is this a difference of two squares? The answer is a resounding heck no. They're adding. It's not a difference, that's a sum. So this is completely factored, ladies and gentlemen. Can't go any further. All right, I'll do these two, and that'll conclude the video. All right, so 18, 24, and 10 all divisible by 2. When we do that, we get 9x squared plus 12x minus 5. Now, I wanted it to be a perfect square trinomial, but that 5 kind of ruins that, so we have to go bubbles for this. So I have 3 and 3, and I have 9, and I have 1. Here I have 5 and 1. That's it. I'm trying to get a positive 12. Okay. So what I'm going to do... Okay. 3 and 5 is 15. 3 and 1 is 3. And if I make that negative, that'll get me the positive 12x. Okay. So I'm going to go ahead and do this, and I'm going to get it wrong so I can show you how to get it right. So these are both my x's right there. Don't like talking about them. And since I made this negative, I have to make the 1 negative. So let me start pairing up. 3x gets paired up with the positive 5 there. There's that line in there. And then I have the other 3x gets paired with the minus 1. Okay. Now, I said I was going to get it wrong. The only thing I did wrong is I forgot all about this guy right here. If I took a 2 out to begin with, that 2 needs to follow it down. This is perfect. Okay. On the next problem, I'm going to factor out a 3. When you do that, you're left with x squared plus 8x plus 15. Okay. Meaning, now, since that is a 1 right there, we can use the x method on this. And what are two numbers that multiply to 15 and add up to 8? Well, that's a great question, Mr. Byrne. I would say maybe 3 and 5. And Mr. Byrne, you're correct. So we have x plus 3, and we have x plus 5. And Mr. Byrne, you have forgotten something. Mr. Byrne, what did you forget? I'll tell you what you forgot, Mr. Byrne. This 3, when you pull it out, it has to follow it. So there is the answer. Oh, thank you very much.